Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video, I'm going to solve the CAIE 5070 past paper 4. I have selected the paper 41 for October-November 2022. So instruction for this paper is answer all questions, use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. You should show all your working and use appropriate units. Information. The total mark for this paper is 60. The number of marks for each question or part question is shown in brackets. So here's question number 1. Two gases A and B have the properties shown. A, less dense than air. B, less dense than air. A, it's insoluble in water. B is soluble in water. A is colorless and B is brown in color. Some sets of apparatus P, Q, and R used to collect gases are shown. This is P, Q, and R. A, name apparatus B. It's a boiling tube. So you write boiling tube. B, Q is used to collect gas B. This is Q. It's used to collect gas B. Number 1, state why R is not used to collect gas B. So gas B is soluble in water. That's why you can't use R to collect B. So you write soluble in water. Number 2, state why P is not used to collect gas B. If you look at the density of B, it is less dense than air, so you can't use P to collect B. Can't use. So you write it's less dense than air. C, state why R is more suitable than Q to collect gas A. Because gas A is insoluble in water and it wouldn't be possible to tell when D was full. You are using D to collect A. Number 2, student electrolysis two aqueous solutions using the apparatus shown. A, complete the table. We have solutions aqueous copper 2 sulfate and concentrated aqueous sodium chloride. For aqueous copper 2 sulfate at anode, will get oxygen. The observation will be bubbles of colorless gas. So you write bubbles of colorless gas. At cathode, we will get copper solid. And the observation will be pink or brown solid deposit. Pink or brown solid deposits. For aqueous sodium chloride, at anode, the product is chlorine. The observation will be yellow-green gas, bubbles of green gas. Bubbles of yellow-green gas. At cathode, hydrogen will be produced and observation for this gas will be bubbles of colorless gas. B1, describe the test used to identify chlorine gas. The test will be litmus paper. Bracket you write damp. And the observation will be, it will turn to red, then bleach. Turn red and bleach. Number 2, chlorine gas is toxic. Describe a safety precaution that the student should take before because of this hazard. Use fume cupboard. Question number 3. Calcium carbonate reacts with dilute hydrochloric acid. This is a reaction CaCO3 plus 2HCl gives CaCl2 plus CO2 plus H2O. The student investigates the rate of this reaction using 3 different concentrations of hydrochloric acid. So this is the apparatus E. We have loosely fitting cotton wool plug. We have dilute hydrochloric acid in E. We have sample bottle containing calcium carbonate, and this is the balance reading. The student adds all of the calcium carbonate in the sample bottle to the dilute hydrochloric acid in E, replaces the sample bottle on the balance, records the mass every 30 seconds. A, name apparatus E, it's conical flask. So we'll write conical flask. B, carbon dioxide gas is a product of the reaction. 1, describe the test used to identify carbon dioxide gas. It's lime water. The observation will be white precipitate. Number 2, explain why the mass decreases as time increases. The gas produced, or you can write gas escapes in the air. You can even mention the name of the gas. Number 3, student uses the measurement of mass as time increases to determine the rate of this reaction. State a different measurement that the student could make as time increases to determine the rate of this reaction. Can have volume of gas. You can even calculate the change in volume of gas. C, in each experiment, each of the 3 experiments, the student uses a different concentration of hydrochloric acid. All other variables are kept constant. The 3 experiments are labeled X, Y, and Z. You see the concentration, difference in the concentration. In X, the student uses 1 mole per dm cube. In Y, he uses 0.5. In Z, 0.25 mole per dm cube. The hydrochloric acid is in excess in each of the 3 experiments. A catalyst is not used. Identify 2 variables that should be kept constant in this investigation. The temperature must be constant. or mass of CaCO3 or the particle size or surface area. Particle size or surface area. Number D, the student plots a graph of the results. This is the result. 1. Describe how the graph is used to decide which experiment has the greatest rate. Steepest gradient or the graph that levels off first. This is a graph that levels off first. We'll write steepest gradient. Or graph that levels off first. Number 2, write a letter in each box on the graph to identify experiment X, Y, and Z. We have X, Y, and Z. In X, the concentration is 1, Y is 0.5, Z is 0.25. For your convenience, I will show you the values 1, 0.5, and 0.25. So, in 1, the concentration is high, so it will level off first. So the first one must be of X, second is Y, third one is Z, X, Y, Z. 3, describe how the graph shows that the reaction stopped. The graphs level off or graph becomes horizontal. Graph becomes horizontal. Or you can write gradient become 0. Number 4, explain why the reactions stop. The calcium carbonate is used up. Number 4, student is provided with 2 bottles labeled A and B and a supply of dilute hydrochloric acid. One of the bottles contains 1 gram of solid potassium carbonate, K2CO3. The other bottle contains 1 gram of solid potassium hydrogen carbonate, KHCO3. The reaction between potassium carbonate and dilute hydrochloric acid is exothermic, which means it releases heat. The reaction between potassium hydrogen carbonate and dilute hydrochloric acid is endothermic, which means absorb heat. Plan experiments using the reaction of each solid with dilute hydrochloric acid to decide which solid is in each bottle. Which reaction has the greatest heat change per gram of solid. Your plan may use any of the apparatus normally found in a chemistry laboratory, but no other chemicals. Your plan must state all the measurements you need to make. Your plan must use the same experimental procedure for each solid. So you have 6 marks question. So first of all, we'll take acids, so both solids with the acid and stir it as both solids stir with acids, and we have to use equal concentration of acid. Concentration of acid is used. You can even write equal volume or equal volume. And note down the temperature using thermometer. Note down the temperature using thermometer. Potassium carbonate gives temperature rise, while potassium bicarbonate, potassium hydrogen carbonate or potassium bicarbonate, potassium hydrogen carbonate shows drop in temperature. Note down the greatest heat change. Number 5, solution K is an aqueous solution of sodium hydroxide NaOH. Student determines the concentration of solution K using a method that involves titration. Student measures 25 centimeter cube of solution K using a pipette. The student makes up the solution to 250 centimeter cube with distilled water. This is solution L. A. Explain why a pipette is used instead of a measuring cylinder to measure 25 centimeter cube of solution K. So pipette is more accurate than measuring cylinder. B. Name the container in which solution L is made. Write graduated or volumetric flask. C. A pipette is used to transfer to 20 centimeter cube solution L into a flask. The pipette is washed out before measuring solution L. Identify the liquid that is used to wash out the pipette. Definitely solution L. So we write L. D. The student adds 2 drops of methyl orange to solution L in the flask and then places the flask on a white tile. The student fills a burette with 0.1 mole per dm cube sulfuric acid H2SO4. The H2SO4 is added to the flask until there is a color change. Number 1, explain why the conical flask is placed on a white tile. See the color change of the indicator clearly. To see the color change, clearly. Number 2, state the color change of the methyl orange indicator at the endpoint. The color changes from the conical flask contains NaOH and we have added acid, that is H2SO4. So in NaOH, the color will be yellow and in acid will turn to red or orange. E. The student does 3 titrations. The diagrams below show parts of the burette with the liquid levels both at the beginning and at the end of each titration. First titration, second titration, third titration. Use the diagrams to complete the table. So final burette reading. For first titration is 23.2. Initial reading 0. Volume of H2SO4 added will be 23.2. Second one, final purity reading will be 46.5. The initial reading will be 24.2. So if you will calculate the difference, you will get 46.5 minus 24.2, 22.3. For the second one, for the third titration, the final purity reading will be 32.1, 2, 3, 4, 5, 6, 7. 32.7. The initial reading will be 10.2. The difference will be 32.7 minus 10.2, 22.5. Now we have to select the best titration results. 22.3 and 22.5 are the best results. The reason is that 23.2 shows the biggest variation in the volume. Shows biggest variation in volume used. Tick the best titration results in the table. We are already done. Use the best titration results to calculate the average volume of H2SO4 added. So what we will do, we will add these two, 22.3 plus 22.5 and divided by 2. We will get 22.4 centimeter cube. Calculate the number of moles of H2SO4 in the average volume of 0.1 mole per dm cube H2SO4 added in E. So first of all, we must have volumes in same unit. So instead of dm cube, I'm writing 1000 centimeter cube. So 1000 centimeter cube contains 0.1 mole. Therefore, 22.4 centimeter cube contains X mole. So do the cross, it will become X is equal to 0.1 multiplied by 22.4 divided by 1000. 0.1 multiplied by 22.4 divided by 1000. The answer is 0.00224. 00224. Or you can even write 2.24 into 10 raised to power minus 3. G. The equation for the reaction of sodium hydroxide with sulfuric acid is shown. 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Use this equation to calculate the number of moles of NaOH in 20 centimeter cube of solution L. So we have NaOH and H2SO4, 2 moles reacting with 1 mole. Therefore, X moles reacting with 0.00224 moles. So X will become 2 multiplied by 0.00224. And if you multiply it 2 by 0.00224, we will get 0.00448. 0.00448 or 4.48 into 10 raised to power minus 3. Calculate the number of moles of NaOH into 50 centimeter cube of solution L. So this is the volume in 20 centimeter cube. So what will be the, this is the moles in 20 centimeter cube of solution L. What will be the moles in 250 centimeter cube of solution L? So 20 centimeter cube contains 4.48 into 10 to the power minus 3 moles. Therefore, 250 centimeter cube contains X moles. So you write X is equal to 250 multiplied by 4.48 into 10 raised to the power minus 3 divided by 20. 250 multiplied by 0.00448 divided by 20. 0.056. Number 1, reduce the number of moles of NaOH in 25 centimeter cube of solution K. We have transferred the 25 centimeter cube of solution K in L. So the number of moles will remain same, 0.056. Number J, calculate the concentration of solution K in mole per dm cube. So this is in 25 centimeter cube. So we write 25 centimeter cube contains 0.056 moles. Therefore, 1000 centimeter cube contains X moles. So we'll write X is equal to 1000 multiplied by 0.056 divided by 25. 1000 multiplied by 0.056 divided by 25. 2.24 mole per dm cube. This will be your final answer. K, student does the same experiment using 20 drops of methyl orange instead of 2 drops of methyl orange. Methyl orange is acidic. State if the average titration volume of H2SO4 is smaller, larger, or unchanged when 20 drops of methyl orange are used. Explain your answer. Definitely, it will become smaller. The reason is that methyl orange neutralizes some of the sodium hydroxide. Smaller because methyl orange neutralizes some sodium hydroxide before even the titration is carried out. Number 6, a student is provided with aqueous copper 2 sulfate, aqueous aluminum sulfate, and aqueous solution labeled X. Student tests the 3 solutions by adding each reagent shown in the table. A, complete the table with the expected observations. So we have aqueous sodium hydroxide, and if we'll add to copper 2 sulfate, we'll get blue precipitate. And in aqueous sodium hydroxide excess, it becomes or it is insoluble. In case of aluminum sulfate, we'll get white precipitate and it will dissolve in aqueous sodium hydroxide. In case of aqueous ammonia, we'll get blue precipitate for copper 2 plus ion. And we'll get deep blue coloration. For aluminum sulfate, we'll get white precipitate and it will become insoluble in excess. The result for X is shown on the right hand side. That is with aqueous sodium hydroxide, red brown precipitate, and in excess it remains. In case of aqueous ammonia, again we'll get red brown precipitate, and again the precipitate remains in excess of aqueous ammonia. So next test is about is for chloride ion, aqueous silver nitrate, and dilute nitric acid. You see, in case of X, they're showing white precipitate, so it must contains Cl negative ion. In case of both copper 2 sulfate and aluminum sulfate, will get no reaction. What about with aqueous barium nitrate and dilute nitric acid? Both copper 2 sulfate and aluminum sulfate gives white precipitate. And in case of X, there will be no change. So now the identity of X, it must contains Fe plus 3 and Cl negative. So we will write FeCl3 or iron 3 chloride. Seven, a student passes electricity through an aqueous solution of zinc sulfate using an inert anode and a zinc cathode of known mass. Zinc is deposited at the cathode. This is the whole setup. We have zinc cathode, inert anode. We have aqueous zinc sulfate. After 5 minutes, the student removes the cathode to determine the mass of zinc deposited. A, state what the student does to the cathode after removing it from the solution, but before placing it on the balance to measure its mass. We have to wash with distilled water and dry. Wash with distilled water and dry. The student measures the mass of the cathode and then puts it back into the circuit and continues the experiment. The student determines the mass of zinc deposited every 5 minutes. So this is the table shown. At 0, you have 0 mass, 5 minutes, 0.29, 10, 0.59, 15, 0.88, 20, 1.20. At 25, you get 1.30. And the mass of zinc deposited becomes constant after 25 minutes. Plot the results from the table on the grid. Draw a straight line through the first 5 points. Draw another straight line through the last 3 points. Extend both lines so they intersect. So at 0, we have 0 mass, but at 5 minutes, we have 0.29 mass. So the mass will be here, 1, 2, 3, 4. This will be 1 point. After 10 minutes, it's 0.59. And after 15 minutes, it's 0.88. So you'll have 1, 2, 3, 4, 5. 0.88. And after 20 minutes, it's 120, 1.20. And after 25 minutes, it becomes 1.3. So you'll have 1, 2, 3, 4, 5. So we have intersected lines. This will be the final graph. And after this, the graph becomes horizontal. C1, use your graph to determine the mass of zinc deposited after 18 minutes. So 18 minutes will be here. You have 16, 17, 18 minutes. So 18 minutes will be here. So you'll have 1.05 or 0.6, 0.5 or 1.06 grams. Use a graph to determine the minimum time taken for all the zinc to be deposited. It's very easy. You look at the graph, the minimum time will be between 20 and 25 minutes. Should be like 22 minutes. That's all for this video. Thanks for watching. Press like and share my videos. Give comments. For more videos, subscribe to my channel and press the bell icon.